All right, for this exercise, I kind of want to do a reorientation. This is something that you would have done in your in your intro class. The word escaped me. Your introduction to gaming class. This is actually on the Unity website, and we're going to do something really, really similar to it, but not exactly the same thing. I'm not just going to refer you to that video because I want to integrate the things that we've been talking about in our lectures and what we've done in our labs so far. So we're going to make the marble game that you started off with again in your original Intro to Gaming course. So let's go ahead and start up Unity. I'm going to create a new project, and I'm just going to call this ball game. I'm going to put it in a particular location though so that I can find it easily. Just let me create a folder, and I'll just say labs. I'll call it lab code. Ball game. All right, sounds good. And I'll click choose. I'm happy with all of this. Click create project, and of course Unity will relaunch the way it does. And there we go. All right. So I'm going to move to the first part fairly quickly because I think this is probably old hat. So let's start off by making the game area itself. So if you recall, this is basically just a simple box. And what you do is you roll this marble around on this box, and you have these pickups that you want to collect. And so it sort of wraps everything that you would want to know about how to manipulate things in Unity into one nice, neat little package. So we're going to start with a cube, and that will be the basis for our gameplay area. I'm going to use a transform tool to squish it down a little bit, and then I'm going to stretch it out in either direction until it looks pretty good. And now I'm going to look over here at my numbers, and it looks like I've got 16 by 18. So why don't I make this about 25 by 25, and I'll make this 0.2 just because that's roughly what it is. I like even, or at least easy numbers, not necessarily divisible by 2, but you know, not 25 point some crazy decimal place out there. So that's cool. All right, so that's going to be our play surface. Let me zoom out a little bit, and I'm going to go ahead and start positioning my camera the way I want it. So I'm going to manipulate the scene until I like the view that I have, and I'll zoom in just a little bit so that I am just above the play area. All right, so that's fine. I'll go ahead and align my camera. To do that, I'll select the camera, and you can see right now that it's almost level with the playing surface, and I want it to be above the playing surface. So with main camera selected, and that's really the trick here, main camera selected, you've manipulated the view so that it looks the way you want it to. Let's go ahead and select align with view, and when we do that, then you can see what happens. The camera moves to the exact location where we are right now, and that's just a convenient way to set up the camera. And later on we'll have the camera follow, but it's not going to change height or anything like that. So that's fine the way it is. Okay. Next we need a few walls around the outer edge. But I think I'm going to go ahead and put some texture on this to make this a little bit easier to see. And I've gone ahead and downloaded some things from the internet. And so I've got them here. I've got this floor tile JPEG, this metal floor tile that I found, and a concrete block JPEG. And it doesn't really matter what you use. I went out and Googled textures, tileable textures for the floor, and it just makes it quick and easy. I'm not going to be worried too much for this course or for our exercises about copyrights and all of that stuff. I know I probably should, but I'm more interested in getting it done. So when you're going for production, you want to make sure that you have rights and releases and all of that stuff. And if you're going to buy assets, make sure you pay for them. Make sure you can prove that you paid for them and all of that neat stuff. But I just find things on free sites whenever I can, and I just use those. as my materials for my exercises. All right, so let's take our metal floor tile and let's drop it onto the floor. And that's kind of large, so why don't we adjust this? And I will adjust this down probably about 3 by 3. Probably is going to look good. Yeah, that looks pretty good. We might go 4 by 4. Yeah, that looks fine. Okay, so I'll stick with 4 by 4. And next I'm going to put some edges around the outside of this. So what I'll do is put another sphere, I'll put another cube out there. And I'll press F on my keyboard. I'm kind of zoomed out quite a ways. I want to zoom in on it or focus on it as the way to remember it. You can either double click over here in the hierarchy and it will take you to it. And it wasn't really small. It just, that's the transformer. It's actually below the surface, which is weird, but that's where it is. The other way to get there, just from zooming out again, is to press F, and that will take you to it as well. And I'm using the roller wheel on my mouse to move in and out, in case you need a refresher on that. So we have the roller wheel will move you back and forth. Right-clicking your mouse will allow you to move freestyle. And you can also pan by holding down the mouse wheel like a button, and that will let you pan around like that, like it's a piece of, like you're scooting a piece of paper around. All right, so we've got our cube. That's going to be our wall, and you'll note from its position it came in at an odd position, and sometimes that happens. Let's go ahead and reset this. So I'm going to reset this just so you remember how to do it. I'm going to click the gear and select reset, and that will put it right at 0, 0, 0. It basically zeroes everything out and sets the scale to 1, 1, 1. All right, so you can see it's halfway sunken into the floor. Not really what I want. Let's go ahead and move it up a little bit so that it's above the floor, and I'm going to sink it back out down in just a little bit. And that's going to be the basis for my wall. So I'm going to use a transform tool again, and this time I'm going to make it taller. And of course I'm making it taller down as well. I'll squish it a little bit. And now I'll use my transform tool again, selecting just one axis. Now it's probably a little too tall. I didn't really want it to be that tall, so I'll squish it a little bit. And that's probably about right there for what I wanted. Okay, so I'm going to move it down again so that it just squishes through that floor a little bit. And now I'm going to move it back. Now you'll notice I'm using these arrow tools, these axis tools, judiciously. That allows me to move things along one axis. If I wanted to move it freeform, I could click here in the middle and move it however I'd like, but that's fairly imprecise. So I usually just move things along an axis. So I'll move this back to here, and it would probably be nice if I could see it from the top. So I'll click the y-axis and see it from the top, and if I have to zoom out, that's okay. I want to turn off perspective on this, because it just makes more sense when I'm making a wall to be able to see it without the perspective. You can see the foreshortening makes it look kind of funny. So I'll turn that off, and that's a little nicer. So I'll go ahead and stretch this out. And I'm not going to spend a ton of time trying to make it perfect, because you don't want to sit here and watch me fiddle with dials for a half an hour. So I'll come close and call it done. All right, now on this one, I have this nice concrete block texture, and that's what I'm going to use for this one. And I'm just going to drag it and drop it on there like so. And I can adjust this as I did the other one. So 4 worked before. Let's see how 4 looks here. Probably okay, but again, I don't want to spend a ton of time trying to make that look perfect, because that makes for a rather long lab. So I'm just going to leave it there. Probably need to go lower than that. Oh, I put 14 in there. That's the problem. Let's go with like 2 and 2. Okay, now I can actually see some of those lines. Okay, so that's good. I'll go ahead and save this because I haven't saved it yet. So I'll save my scene. And I'm going to call my scene main. There's only going to be one scene in here, so I don't need to worry too much about it. And there's my scene. And now I just need to duplicate this wall 4 times. So I'll zoom out a little bit again with my mouse wheel. And with the wall selected, you can use Control D on a PC or Command D on a Mac. and that will duplicate it. You can see over here in the hierarchy that I now have cube 2 and cube 1, and now I can just move this up here, and I can duplicate this again, either Command D or Control D depending on what your platform is, move it up to the middle, and now we want to rotate it. So the rotation is here, and you can actually use keyboard shortcuts for this. You can do Q for the hand, W, E, R, and T will get you those buttons across the top. So it's Q, W, E, R, T. It's just the first 4 buttons on your keyboard above home position, if you remember how to type. All right. So we've got cube 1 selected. Oh, I actually moved it, didn't I? I didn't mean to do that. I was like, where'd my other wall go? That's okay. I'll just go ahead and duplicate this and move the duplicate back. Or move the original back, rather. That's what I meant to do. And then I was going to select the one in the middle and then rotate it. So select the rotation tool and rotate it a little bit. And you can rotate it this way, or you can just come over here. We know it wants we know we wanted a 90-degree rotation, so you can just plug 90 in there, and that's fine too. And now we can come back over and translate it over. And again, you'd probably want to spend some time making the corners line up really well. Sometimes you'll get flicker in there if you don't, but I'm not going to worry about that for this tutorial. I'll Control D again, or Command D in my case, since I'm on the Mac. And I am going to have some overlap here, but I'm just going to have to let that go. All right, so I'll go ahead and save this, and that looks okay. So next I'll go ahead and add in the star of the show, which is going to be a marble, a sphere. And before I do that, though, I think I'm going to get a little bit organized. So I've got all these cubes running around. It's going to be hard to tell what they are at some point. So the original cube, I'm going to rename that so that it's the floor. And this is a little tricky in Unity. You want to make sure you hit, anytime you're entering anything with a blue boundary around it, if you notice there's a blue boundary around this text box, you want to press enter to make sure that the setting takes. Sometimes you'll change it and then you'll just click off, and usually it doesn't take if you do that. You usually actually have to hit enter in order to get that to set. All right, so we've changed the name of that. Let's go ahead and change these, and I'm just going to call them wall. If you really wanted to, you could call them north, south, east, and west or whatever, but I'm just going to call them all wall for no particular reason. I'm not going to use that in a script or anything later. I just am going to call them all simply. And the thing I'm going to do after that is I'm going to go ahead and get these organized. So I'm going to combine the walls and the floor into one game object. And it's just nicer to keep things organized. To do that, go to Game Object and click on Create Empty. And so we've got this empty game object. So now I can take floor and drop it in here, and wall, and I can do the same with the other walls, and just drag them and drop them in here. And now I'll rename this to walls and floor. And now that's nice. If they're all grouped now, so if I have that selected, I can move the whole thing at once if I need to, and they'll all move together. But it also keeps my hierarchy from being too cluttered up. All right, now we're ready for the star of our... Oh, before we do that, I keep thinking we're ready, and we're not ready. Let's go ahead and go down and organize our assets down here at the bottom. So we don't have a lot in here yet, but it's going to get crowded eventually. It always does. And so let's go ahead and remind ourselves that we can come down here and make a folder. So I can create a folder, and within that folder, I can say things like scene. And then from here I can take my single scene, probably not a great organizational time saver, but go ahead and drop it in there. And we've got materials already. I'll go ahead and put images in here. And if you were watching very closely, you might have noticed that materials got created automatically. So when we dropped our images onto our 3D surfaces, it went ahead and made these materials for us. The images are still separate, so I like to keep those together. Oops. There we go. And now we're getting there. Let's go ahead and make a folder for our scripts, because we know we're going to use some. And that should be okay. I'll go ahead and save my scene again. And now, are we ready? I think we're ready. Let's go ahead and add the ball. Let's create a sphere. And I'll press F again. And I want to see how it's lining up. So let me switch this back to free so I can kind of look at it. It looks like it came in exactly where I want it. It's a little high, a little tall. That's okay. And you definitely don't want it to go through. See how it goes through right there? That can cause problems with your colliders. So if you don't know this already, see this green thing on here, that's called a collider. And you can actually see it here. It's the sphere collider. If I turn it off, it'll become apparent. And that's what that lighting, that lit up green thing is. That's the collider. That's what gives this sort of a physical form in Unity. And so now I've got this down here close to the ground. One of the things that I'll be using in this game is physics. I'm going to use the Unity physics engine. There are several ways that you can move things around in Unity. For example, I could write code that modifies the transform.position property, and of course I can change anything in 3D space because I have our 3D spatial coordinates here. But the other way to do it is to actually use physics, and that's what I want for this project because I actually want this to roll. So if I were just moving it around with the transform.position, it wouldn't be appearing as though it were rolling. It would just appear like it was sort of hovering and moving around without rotating, and that's not what we want for a ball game. So we're going to use physics and actually apply forces to it, and that will cause this ball to roll. So let's go ahead and set this up. With the sphere, I'll go ahead and rename it to marble. I like thinking of this as a marble. With our marble selected, I'll go ahead and select Add Component. And we need to add physics and then rigid body. So this is what turns on the physics engine for this particular object. And none of the other objects have it on there, so this is the only thing in here that's really going to react to physics and gravity right now. So we'll do a quick demonstration of this. Let's go ahead and I'll zoom out a ways. And I still have my isomorphic view turned on, which looks weird. So let's switch it back to perspective. And let's go ahead and move this up a ways so we'll be able to see it. And since we have rigid body on here, it has a mass and all of this neat stuff. Let's go ahead and run this, and we'll actually see this drop to the ground. And there it goes. So when it hits, it doesn't bounce or anything because we haven't told it it's made out of any particular material, but it does go ahead and react to gravity. It falls to the ground. So why don't we go ahead and make this bounce a little bit? In order to do that, we need what's called a physic material, and you might notice the distinct lack of S on the end of physic. It's right here. That's what it says in UI, so that's how I pronounce it. In order to make one of these, we need to go down into our assets area, and let's right click anywhere in here and find the under the create menu where it says physic material. I'll select that and we'll give it a name. I'll call it bouncy material. And now with that selected in assets, you'll note that the inspector has the properties for our material, which by definition isn't necessarily bouncy. You can use this to simulate a lot of things like ice, I guess water, anything that will slow something down or speed something up. It's just designed to simulate a surface material. And in this case, we're going to kind of give it enough bounce for it to be maybe plastic, but not necessarily like your old school bouncy balls that we played with when we were children, or still play with them with our children, or just play with them without children, whatever you like to do. All right, so on bounciness, if I hover over this, I can see that it eventually gives me these braces and it says 0, 1. So that means it's expecting a number between 0 and 1. Well, I want this to be fairly bouncy. So I'll hit 1 and let's see what that gives us. Oh, I forgot to apply it, didn't I? Okay, so I've got the material and I forgot to apply it. So let's apply it. I click the ball and there's the slot for it right there. So I need to drag this and drop it. So select bouncy material, drag it over, and drop it in there. And now we should get a better result. Let's go ahead and save. And now it should bounce. Not bad. We still haven't written any code. This is pretty good. Now if you want to, you can change the mass, and you can fiddle around with the settings here, and you can also fiddle around with the settings in bouncy material and really make this thing bounce and do different things depending on what you're after. I'm just sort of here to remind you where some of these things are. Let's give this a mass of about 20. I don't remember what they did in the original tutorial, but that sounds about right. And let's see if that affects the bounciness. Doesn't seem to very much. But it will affect other things like how difficult it is, how much force you have to have in order to move this thing. So it's fine that we selected that and set it to 20. And you'll note also that there's this use gravity checkbox. If I turn this off, it will pretty much suspend the laws of gravity for that particular object, and it will just sit there. So this is handy if you're going to make like a 2D game and you want physics in there, but you don't necessarily want everything falling. So that checkbox is there in case you need to turn it off. And there we go. So we'll just turn that back on again and make sure it still works. And okay, so now we're all set. Now what we need is a script that will actually allow us to control the movement of the ball. So again, make sure that the sphere or the marble is selected, and let's add a component, and let's slide down here to new script, and let's add a script. I'm going to call this marble controller. We like to make things controllers in Unity programming for whatever reason. And so I will click create and add, and that added our script. So let me double click this. All right, now that MonoDevelop has come up, we're going to write the code that will control our marble. So what we're going to do is we're going to take advantage of these event handlers that Unity gives us. And there are dozens of these things. In fact, there's an assignment that you can do where you're supposed to write a paper that basically covers what all of these do. Paper is kind of a loose term in this case. It's not like going to be a formal research paper or anything like that. It's really more of a, I would call it a job aid, where you actually go and research what all of the events do. I highly recommend this if you intend to be a professional Unity programmer, because you really need to understand what all the different events are. So for example, there's update, but there's also late update, fixed update. There are several different variations of update. So when do you use update versus fixed update? These are things that that particular assignment will teach you. So again, highly recommended. All right, so before we get rolling, let's put a little bit of code in here, and then I'll show you where some of this is coming from. So I'm going to create a variable, and I'll call it movement x, because it's happening in the x-axis. And I'm going to set that equal to getAxis. Oops, sorry. Input.getAxis. .getAxis. There we go. Okay, so the input is the class that comes with the MonoBehavior class. So you can see there at the top we're inheriting from MonoBehavior. So anytime you see something, it's like, well, where's that coming from? More than likely it's coming from MonoBehavior. So in this case, we've got this object called input, and we have a method on that called getAxis. And getAxis is going to take a string, but I'll go ahead and open this up so you can see that in fact it does take a string. There aren't any overloads for it. And it wants the axis name. Well, what is the axis name? Well, I'm going to leave it blank, and we'll go look it up. Okay, so whatever that is, it's going to be a string here in just a minute. So let's go ahead and do var movement y, and we'll say input.getAxis, and we'll do the same thing here. All right, so what are our axes called? To find this out, we'll switch back over to Unity, and I'll show you where the axis names are. You can actually change them. No, I've never actually seen that done. It is possible. So let's go over to Unity and let's find our project settings, which should be under Edit, Project Settings, and then select Input. And it seems like nothing happened, but it did. What changed is your inspector. So come over here to Inspector, and let's open up where it says Axes, or Axes. If we were making a Dungeons & Dragons game, it would totally say Axes. And let's find what all these different things are. So we've got horizontal and vertical. So let's go ahead and open those up. And look, we can see the names are horizontal and vertical. You could change them if you want. You could make them to horiz and vert if you wanted to shorten them down. I guess if you spoke a language that wasn't English, I don't know how that works in Unity, if you can install it in a different language, and these will show up with localized versions of these words, probably. But if not, then you could certainly change them. So if you speak Portuguese or Spanish or something and you want to change what they are to make more sense to you, then you can do that. But we're not going to do that. So we just need horizontal and vertical. So let's switch back over to our code. And we'll simply type in here horizontal. You have to spell it correctly, and you have to match. It has to match what says here. So that's the takeaway here. And then the other one is called vertical. And I'll go ahead and save that. And next what we'll do is we'll go ahead and start figuring out how to move our marble. It's not a lot of code. In fact, it's 1 or 2 more lines and we're done with this part, so that's good news. In order to move something, we're going to need a direction in which we're going to move it. And actually what we're going to do is we're going to apply a force, a physical force. Envision blowing it or pushing on it or exerting some sort of force on it. And anytime you want to do anything with a 3-dimensional coordinate, you use what's called a vector 3. A vector 3 is just very simply a custom type that's in Unity that lets you use 3 numbers, x, y, and z. So don't let the word vector 3 fool you. It sounds very, very technical, but really it's just 3 coordinates together in one convenient package. So what I'll do is I'll go ahead and create a new variable, which I'll call direction. And I'll create a new vector 3 from this. And I have a couple of options. So I'm going to, having hit open parentheses, I can see this 1 of 3 here. I can see that I have a number of options here. So I could just close it and leave it like that. If I use my arrow, my up and down arrow keys, I can see what my overloaded options are. So remember, this is method overloading. We talked about this in the lecture. And so I can see what all the different method signatures are. So I can pass in an X and a Y and leave Z to be whatever. Probably makes more sense to pass in an X, a Y, and a Z, which is what we're going to do. So I'll go ahead and give it 3 numbers, and it wants floats, so I'm going to go ahead and give it float. And for now, I'm just going to give it movement X and movement Y and 0 for Z. And that's fine. Now the only problem with this is that the numbers that you're going to get back from horizontal and vertical on the get axis call are going to be tiny. They're going to be between 0 and 1, as many things in Unity are. You can pretty much almost bet that anytime you're getting a float back, it's going to be a number between 0 and 1. So they're small numbers. That's nice. They don't use much memory, even though they're floats. And that's just usually how things work in Unity. So envision moving something a fraction. And you can imagine the problem that we're going to run into, right? This ball is going to move like really, really slowly. So by and large, what we wind up doing is we create some sort of multiplier. So let's go ahead and put a multiplier in here. I'm going to come up to the top, and I'm going to make a public property on this class. So I'm going to say public, and I'll call it a float, and I'm going to call this speed. And I'm going to initialize it to 30 F. Now, I really went out of my way to make this obvious. I could have done 30F like that. I probably could have gotten away with 30.0, but I like being really explicit, so we'll go this route. So 30.0f, the f means that it's a floating point number. Envision this right here. It doesn't know if you're assigning this correctly. This could be an integer, it could be a float, it could be anything, right? So if you leave nothing to the imagination, then you'll be much happier in Unity. So let's do 30.0f. Or you could do 30f if you wanted to save yourself the keystroke, but the f is important. All right, we've got that. Let's come back down to direction, and let's change this so that we're actually going to multiply this by whatever the speed is. And what will happen is it will multiply all of the vectors, or all of the points inside of the vector 3 by speed. So I'll go ahead and save this, and I want to point something out before we do the next line of code. Let me switch back over to Unity. Having added this as a public property, we should be able to switch back over here, and we should be able to see, if we select our marble, we should be able to see speed here, and it should be editable. If we wanted to change it to something like 40 or 100 or something like that, we can change it. So again, that's the nice thing about public and private properties in Unity, is that you get them exposed here when you create component scripts. So that's nice for people that are not so much coders, they're more level designers. They really want to come in here and tweak things, and that's a good use of their time versus your time. If you're the programmer, then you really probably need to be focusing on programming tasks, not figuring out what the optimal speed is to make this a fun game. So your job is usually to expose these things and let the level designers that are responsible for making the game fun and organized and cohesive, leave that to them. Those are details that they can do without having to be able to get into the code. And so that's a good thing. That's what those are for. All right, let's switch back over to MonoDevelop. All right, so let's do rigid body. Remember, we put this rigid body component on there. So we're going to say rigid body dot add force. Oh, this is not looking what I want it to look like. Rigid body is the class, right? Now what I want is the rigid body that's actually on the object. So this is a little gotcha that I wanted to warn you about. You're going to see these in the code. So anytime you see something with a big letter versus a little letter. Let me show you another one that really stands out. This particular object has a game object on it, which sounds kind of confusing, but everything pretty much does. So I can say game object, and I'm referring to the local instance of game object, but notice there's also a big G here. The big G game object refers to the class game object, and the class game object has lots of static things on it, so I can actually come in here and do things with game object, and that's going to be a completely different set of things than if I say game object like this. And now I'm actually talking about the local instance. So the little g versus the big G, the little first letter versus the big first letter. So that's something you want to watch out for. When I typed in game object, you can see that there's also the designation P and C. P is a property, so it's the property on this particular class. It comes from MonoBehavior. That's why you don't see it in the code. And then the other one is C, the class game object. So make sure you've got the right one. So I want the local version of, or the local instance of the rigid body. So I should be able to type oh, it's not here. Okay, well now I have to figure out how to get to it. So this is one of the challenges that you have as Unity developers. How do I actually get to a thing or a component on this current object? And let's go ahead and fix this. So what I'll do, there's lots of ways to do this. I'm going to show you the way that I like to do it. I'm going to go ahead and come up here and I'm going to create a private variable. And it's going to be of type rigid body. And I'm going to call it rigid body like so. Okay, so that's nice. That's you don't have to call it underscore. That's just a convention that I use, and a lot of people use this. And so anytime something's private, it's got an underscore in front of it. So if I see something in my code and maybe I'm way down on the screen somewhere and I can't see the top of the file, I know by looking at it that that is a private variable. So that's just a nice thing. But you're going to see a lot of this too. So that's fine. There's nothing wrong with it. But I'm going to stick with that. All right, so I've got this rigid body, And what I need to do now is I need to set it. And this is the perfect place to do it, right here in Start. Now remember we talked about constructors. And a constructor is a function that runs automatically on instantiation. But Unity has this start thing, this start function that's almost pretty much the same thing. So you can think of it as a Unity specific constructor. And we're going to use this. So what I'll do is I'll say rigid body. And you'll note that it shows up now that I've created that variable. And I'm going to set that equal to, and now we're going to do our little game object, .get component. Now, one thing I want to point out here, note that there's get component, singular, and there's also get components, plural. So there are a lot of components where only one can exist. And when there's only one that can exist, this is a pretty safe call to make. If I say get component rigid body, you can only have one rigid body on here. So that's pretty cool. But if you had multiple components on here, say you can have multiple scripts, you can get access to all of your scripts at the same time by getting multiple components. And that will give you back what we call an array or a collection. Now, we haven't talked about that yet, so we're going to let that go. But I want to point out the difference between the T just by itself, the singular version and the plural version of this. There's always both of them in there. And you'll notice that there's get component in children, get component in parent, get components, plural. There's plurals here. So watch out for your plurals. It's easy to make that mistake. If you put an S on there, you're going to get something you're not expecting back. So let's say get component. And now I'm going to use an angle bracket here and tell it that I'm looking for the rigid body component. Anytime you see an angle bracket, what you're really telling it is I'm looking for something of a particular type. So remember we had this long lecture on variables and how variables have shapes and they have sizes and they have types, and rigid body in Unity is a type. So we talked about primitive types, but we also talked about objects, and objects can be types as well. So in this case we're saying get rigid, or we're saying get component and rigid body, and again you can only have one, and so this is totally safe. You say get rigid, or if you say get component rigid body, it knows what you're talking about because there can only be one on there. All right, so this runs at the beginning. Start runs as soon as the game begins. Essentially, if we were to come up here and click start over here, then all of the scripts that have a start function in them would go ahead and fire. And so this is safe. This gets instantiated right away, and now it's ready to be used down here. So now I can say rigid body dot add force. Now we're cooking with gas. We can see all the things that we were expecting. That is going to be a different list than if I had done big rigid body. Let me see if I can get away with this. Let's go ahead and finish this out. We'll say add force, and we want the direction, which we've already established. Okay, what I wanted to show you was if I do rigid body big R, I'm going to get a different list of things. So if you see it turn green and you're not finding what you're looking for, those are all visual clues that the IDE is giving you to let you know that something isn't quite right. So hopefully those are enough visual clues to get you going. And we're almost ready to try this, except I realize I have made a pretty catastrophic mistake up here. I've got movement X and movement Y. Well, Y is up and down. If I move this, I can see Y is up and down. I think there's actually a test question on which way Y is, or which way up is in Unity. So I'm kind of ashamed that I screwed that up. Okay, I'm being a little bit tongue-in-cheek. I knew that Y was up. I want to show you something interesting that we can do in the IDE. Most good IDEs support something called refactoring, and we've mentioned refactoring in the lectures. Refactoring is when you actually change something in your code. You clean it up, you make it nicer, you do whatever, but you're not adding any new functionality to your code. You're not adding new methods. Well, I guess you could be. You could be extracting things out, but you're not adding new functionality. So in this case, if we consider this update method pretty much done, here's what it does. It gets the axis, it computes a direction based on the axis, and then it adds force to a rigid body, and that's what it does. So that's fine. But I've made this mistake here. This should not say Y, it should really say Z. So there's two things that I need to do. First of all, I need to move this out of this position, and I need it to be last. So I'll say movement, I'll go ahead and make it movement Y again, but it isn't really Y, is it? That's kind of confusing. So I've got something called Y and it's in the Z position. So what I want to do, I could go ahead and just change it here and then change it here, and that's fine. But what if I'm a really bad typist and I make a mistake? Well, that's going to throw a little bit of an error, and it'll be a shallow error. You'll see it right away and you'll fix it. It's not that big a deal. But what if you have this like 100 times throughout your whole program? Wouldn't it be better if you could just change it in one spot and it automatically changes it everywhere? And I know what you're thinking. We'll just do a global search and replace. Okay, that's nice too, but there are instances where you don't want that to be. So maybe you've got something with movement Y in the name of something. Maybe I created a variable called movement Y, I don't know, parity variable. I'm just making something up. Doesn't matter what it is. If I did a global search and replace, I'm actually going to change that variable too, and I don't want to do that. So what is a good programmer to do? Let's double click this thing, and so it's selected, and I'm going to right click it, and I'm going to select refactor and then rename. And when I do that, I can type in movement Z, and you can see immediately what it's doing for me. It changes it everywhere where that's referenced. I press enter, bada bing, bada boom, there you go. It's changed in both places, and if I had them 100 times, then it would have changed all 100 of them. And it's not a global search and replace. It's literally something that the IDE is doing. It's going through and parsing the file, and it's figuring out that this is an actual variable name, and it's changing it accordingly. Okay, so that's pretty nice. I got all this ready to go. I could switch back over to Unity at this point and see if I'm good to go, but I can also do it here. So why don't I switch to up here, and I'll just run this real quick. I'll come up to build and select build C#. You want this second one here, this build assembly. And if everything goes well, you should see it up here, build successful. So if you want a bit of a spoiler before you switch over to Unity, I like knowing before I switch over if it's going to work or not. So let's switch back over and give it a try. All right, so as soon as I switch to Unity, I want to look down here at the bottom and make sure that I don't have any red down here. Usually if there's a programming mistake, it'll show up here. Of course, I know there's not because I built before I switched over. But if there were a problem, it would show up there, or it would show up over here in the console. And if you don't see the console tab, you can always find it by going to Window, Console. It's always the one at the bottom. So that will cause the console to show up. All right, we're not going to need that anytime soon, so I'll switch back over to Project, and let me go ahead and run this and see how things work. I should probably move that marble back down so I don't have to wait for it to stop bouncing, but nevertheless, I'm pressing the up arrow, and uh-oh, I'm going the wrong way. Let me just make sure I can press the down arrow and go back the other way. Okay, so we're fine. So all this is an alignment issue. Let's fix this the easy way. I'm just going to basically turn this around so we're looking at it from the other side. And we'll get it lined up and looking nice, a little bit nice. Okay. I'm obsessing, aren't I? Okay, that's fine. Like that. I'll stop obsessing. Click on camera, and let's realign our camera. So it's game object, align to view, and now let's run it. And now we should be able to press up, and the ball goes up. And we press down, and eventually it will change course. And clicking left and right will move the ball left and right. But it is sluggish. Now it's supposed to be sluggish. It's not supposed to be fast, because that's what will make the game hard or difficult. Okay, and it is bouncing off the wall. So that looks pretty good. I'll go ahead and save that, and I will go ahead and move this back down so that I don't have to wait for it. And I'm clicking the wrong axis. Let's see. We'll just come at it sideways. How's that? There we go. Okay, I'm in again Control or just F will zoom you in, and I'm just going to move this down until it almost sinks into the ground. If I put it too far, I run the chance of fall through, which is fun the first time you see it. Not enough. And it just falls to the floor. So that's what you want to avoid. And incidentally, that's why we used a cube instead of a plane for this. You can have problems with colliders if you just have a plane, because it's essentially a two-dimensional surface. It has no depth, and so it's tricky to actually detect collisions against a plane if you're using that for your ground. And so I suggest going ahead and picking up the penalty of the extra 4 or 8 polygons, or however many it is. It's not very many, to actually go ahead and use a cube when you're talking about the ground. Assuming it's flat, of course. Okay, so let me make sure I'm still okay. Good, we don't have that bounce, and that's pretty good. It would probably be a good idea to put texture on that so I can actually see it roll. But I'll leave that to your imagination. If you want to go find you a soccer ball texture, that works well, or a marble texture, something along those lines. I'll probably do that at some point, but you've already seen me drag and drop stuff on here, so you probably don't need to watch me do that again. All right, so we've got our ball rolling around. That's great. Let me save my scene. What do I want to do next? Next, I'm going to go ahead and start making the pickups, the items that this will collide with, in order to give you some points. So let's do that. There's a couple of options here. We could make coins. We can make boxes. I think the original made boxes, so why don't we make coins? Just so it'll be a little bit different. I'll create a game object, 3D, and this time I will make a cylinder. And there's my cylinder, so why don't I make this a little bit thinner. And now I'll go ahead and rotate it. And I can see that's in Z, so why not I just go ahead and come over here and type 90 in here so that it's nice and even. There we go. And that's going to be our coin. And it's important that you move it down so that it will actually be on the same level as your ball. Otherwise, if you put it up here, your ball's never going to get it, right? So make sure that it's down here where your ball can actually collide with it. It doesn't have to be ground level, but it does have to be good enough to where the ball can actually collide with it. All right, so there's our coin. And again, you'll probably want a nice gold texture for that. So now we just need them to spin. So what we'll need for that will be a script. So with this selected, I'll select new script, and I'll call this coin controller. And let's double click coin controller, and it'll open up. And now we just need to make this rotate. Well, we've done a rotating cube lab already. So what I want you to do is go ahead and stop the video and see if you can do this based on your previous experience. Now, it's okay if you go look stuff up. I won't hold that against you, because that's 99% of what programmers do, to be honest with you, is we remember where stuff is and how to look stuff up and how to find things. And that's really our talent, is the ability to look stuff up and understand it and apply it is probably the most important thing. That's more important than memorizing stuff. And I know what you're thinking, so why do we have exams? Well, that's just how it works. Sorry about that. But I do let you look stuff up on the exams, so I think it's all fair. So why don't we pause and you see if you can implement update. If you get stuck, I'll give you a hint. You can go out to the Unity site and find the spinning cube code. They have the exact same exercise that we did, and you can just go find their code and figure out what they did, and then you'll be able to make this work. So stop, pause, see if you can make it work. And we're back. I didn't actually ever stop, actually. I just kept it rolling. Okay, so if you want to go find it, it's pretty straightforward. Just come out here, as mentioned, Unity 3D.com, and you can just type in spinning cube here. And there it is. And there's a nice video, not unlike mine. And that's what we're looking for. Transform.rotate, vector 3 up, speed times time.delta time. So let's copy that. And then we got to remember to make a speed variable that's different. Oh wait, we can use the same one. Why is that? Because the other speed is in marble controller, and this one is in coin controller. So they're different objects. So it's totally legal to have them be the same. Remember, we talked about them being, the variable names have to be different, or they can't be the same within scope. Well, they're within different scopes. They're within completely different classes. And so it's okay to reuse. And that's not what I wanted. I wanted it to say, what would it be? A float, speed. Oh, and it's a public, because we want to be able to change it. And we'll set this one equal to 15.0f. Okay, and we'll come down here to update. And we'll paste that in. Oops, wrong key, sorry. There we go. So now we've got transform.rotate vector3.up. Now remember, we saw this vector3 stuff, and we see that it's green. And so that tells us that it's a class. And we've got all these methods on here. So up is one of the properties that's on that class. So it'll always give you whatever up is. So what I want to point out here is that we did not have to instantiate vector3 in order to get to the up property. This is a special kind of property. It's called a static property. So when you make static properties on your objects, you don't necessarily have to instantiate them in order to use them, and that's handy. You're going to see a lot of static classes and a lot of static properties in Unity. So we make wide use of these things. So that's where they're coming from, and that's why you can get away with that. Speed, we already know what that is. Now I noticed that I made mine capital S, and this one is a lowercase s. So this is not going to build. If I try to build this, it's going to go, I don't know what speed is. And there it is. So that's because these two have to match. So this is probably the number one thing that new programmers have a hard time getting used to, is you declare it up here and use it down here. They have to be spelled the same, up to and including capitalization. Capitalization counts. So uppercase S, lowercase s, you could name them that way and have one called float with a, or s with a capital S, one with speed with a lowercase s, and those are different variables. So just be careful. I wouldn't recommend doing that, by the way. That's a bad idea. It'd be very confusing. You wouldn't be able to remember which one was which. But anyway, there you go. And then we've got this time.delta time thing. This is a unique construct in Unity. What this is doing is, time is pretty self-explanatory, right? It's just that forward-moving vector that we all experience. Time travel is in fact possible because you're doing it right now. You just can't go backwards or forwards at an accelerated rate, right? That's what we really want to do. But time is a really important element in your game. And one of the problems that you run into is hardware. Some hardware is faster than other hardware. And so what you can do in order to mitigate that is you can use this time.delta time function. So what this tells you is how much delta time. Remember, delta from mathematics means or science means change. Anytime you see delta, it means how much is changed. So what this is telling us is how much time has passed since the last frame. So you can imagine how that will help you. On a fast computer, this will be a tiny, tiny, tiny number. And on an extremely slow computer, this will be a larger number. And so what that gives us is a way to sort of smooth out how things work on fast versus slow machines. So we have this nice little multiplier in here, and it will make it look very smooth. So that's what that's doing for us. And there are a couple of time functions you're going to use, but that's one of them. And again, this is a static class, which is why we didn't have to instantiate time in order to use it. All right, so that is all set. Let's go ahead and I've already saved it. Let me make sure this builds. Okay, we're good. It's build successful. Switch back over, and we should be able to see this guy spin. And he is spinning, I just can't see it. So, okay, what's the deal? Well, look, I can tell he's spinning because I can see his rotation changing here. It's an axis problem, isn't it? It's spinning, but it's spinning like edge on. So it's spinning like you're looking down at a record. So you may think that you've done something wrong, but you haven't. You can actually see that it's spinning. It's just not spinning the way you thought it was going to spin. So why don't we change this? Let's change our code so that it spins in a way that is more useful. So we've got vector3.up. And so what does that do for us? That tells us which axis we want to spin around, what other ones, what other options do we have? How about forward? Let's see what that looks like. Don't forget to save. Okay, now we're spinning in a different direction. That's kind of cool. That kind of works. It's kind of slow though. So why don't we stop this and select our coin, and let's set our speed to something else. Like, well, why don't we go with 30? It worked before. And that's a little better. We could probably go a little faster even, but that's not bad. That's actually kind of slow and kind of good. I like that. Let's try 45. Make sure you hit enter or it won't always take. And I think I like that. I'm going to stick with that. That's fairly dynamic looking. All right, so that's good. I'm going to find a texture for this thing because it just looks weird having a white coin there. So I'm going to pause and go find something and come back. I suggest you do the same. Okay, I just punched in gold texture, and I'm not going to spend a lot of time figuring out which one of these to use. I'm just going to grab one. This is the kind of thing I would probably make in Photoshop rather than risk a lawsuit or anything like that. I'm just going to save this image and put it on my desktop. Right now, I'm hoping that this falls under fair use. And I'm hoping my wife didn't hear me say the word fair use, because now she's going to come in and use her super lawyer powers on me. All right, so she didn't, so I guess we're good. So I saved that, and now let me go find it. Hopefully I saved it on my desktop. I should have paid more attention instead of making fun of my wife, right? There we go. Okay, so there it is. I'm going to rename this to gold. Gold texture, so I know what it is. And I'll drag it and drop it into my assets. Probably would be better in images, but I'll put it in there in just a minute. And I'll go ahead and drag this and drop it onto my coin. And there it is. Now I've got that nice gold tint to it. Now I could probably spend a lot more time actually making it shiny, maybe glow, do something cool like that, maybe reflective. But this isn't a shading class or a texture class or a lighting class. It's a programming class. So let's stick with programming for now. And so now we've got our gold coin, and naturally we don't want it to start off here, right? We want it to start off probably like over here somewhere. So I'll move it. And there is one more thing that I need to do here, and that is to set this up so that when the marble collides with it, then it actually gives us some points and then disappears. So why don't we work on that next? We've got our coin controller already, so let's go back in there. But before we do that, what we need to make sure is that we have a collider on this, and we have a collider. We got one automatically when that came in. And I just noticed that this still says cylinder up here, so why don't I go ahead and change this to coin so that we know what it is. All right, so that's good. Coin controller, we've got our capsule collider. What we want to do now is we want to react to a collision. So we'll do that. Let's go into coin controller. And for this one, it's basically going to react to a collider. So there are several events that you can use here, and I'm going to use on trigger enter. Now in order to make this work, I'm going to have to go back into Unity and make an adjustment. So let me do that really quickly. I haven't saved yet, so it's not going to blow up, but if it blows up, it's not the end of the world. So let me switch back over to Unity, and with my coin selected, I want to find my capsule collider, and there it is. And I want to make sure I have is trigger selected. So when I do that, something magical happens to the collider. When is trigger is selected, this will allow me actually to roll my ball through this thing. And what it's telling it is, instead of it being like a physical collider that gives it sort of dimension in space, sort of an impermeability to it, you can actually go through it now, but the trade-off is that now it's going to trigger an event that I can respond to. And so that event is what I was just typing in Mono Develop. So let me switch back over to Mono Develop. On trigger enter, there are 3 trigger events that you can use. There's on trigger enter, on trigger, I think it's on trigger exit, but it could be leave. You'll have to look it up. On trigger enter we use all the time, so that one's pretty much memorized. And then the other one is on trigger stay. So that one will fire as long as the two things are touching each other. So that one's not obvious, but the other two are pretty obvious. All right, so this is on trigger enter, and it takes an argument. And again, this is just, you'd normally look this up, but this is one of the things that you do over and over and over again. And so after a while, you memorize it. And the argument that it takes is a collider. And I almost always call this other. It's a habit I picked up from the Unity documentation. It makes sense to me. It's the other thing, right? It's the thing you collided into. All right, so that's the object that you run into. And here's what we want to do. Basically, we want to, on collision, what? We want to add some points to the score, which we haven't really set up yet. And then the other thing that we want to happen is this object should disappear. Okay. So let's leave this. Let's actually make this a to-do item. I'll type in to-do like that, and that will give us this nice to-do comment, and the IDE can actually track this stuff for you. So that's why it's highlighted the way it is. This will give you a nice reminder to come back later and fix this. So we're going to go ahead and do the disappearing trick first. And that's pretty easy. All we need is the destroy command. Now there's a couple of ways to do this. This is one of them. There are other ways that are probably better, but this one is the simplest and the easiest to explain. So this is a good starting point. So I'm going to select destroy, and you'll note that it has two overloads. The object that you want to destroy, which is just going to be the game object that we're currently dealing with, and then the other thing that we have is T. Now this isn't really documented very well. This is why I'm always on people to make documentation for their classes, and I'm always on people to name their variables well, because now you're seeing how this works. You are a consumer of someone else's class, someone else's object, and they were a little bit lazy, to be honest with you. They put this float T in there, and that is, you don't know what T is. It could be anything. In this case, it's a time, an amount of time that you would like to pass, and it doesn't give you very much information, right? So T, I just know that because of experience. But this is nice because it gives us a slight delay. So let me show you how that works. So we're going to do destroy, and we're going to say game object, little g, because game object is a property on this current object. That's the one we want. We don't want the class. That wouldn't get us anywhere. So little g game object, and we're going to give this about, oh, I'm having trouble remembering. I think it's in milliseconds. So let's put 500 in there, and let's put an F after it so it knows it's a float. And so that'll give us about a half a second delay so that it doesn't quite disappear. It almost looks jerky if you don't put that in there. Plus, eventually we might want to play a sound. So we'll get around to that. And if you destroy it and try to play a sound, it's gone because the sound was on the object and it just doesn't work. So you want a little bit of a delay there. Half a second, which is 500 milliseconds, should be plenty. All right, so let's test this part first. I'll go ahead and save the script, switch back to Unity, and let's try it out. Okay, so it's spinning around. That's awesome. We should be able to roll through it. Now this is where you have to be good at your own game. Oh, we passed through it and nothing happened. Oh no. So we're going to have to figure out why that's not firing. All right, so we've got on trigger enter. That's the first thing we want to do is make sure that I have got all that correct. So let's make sure that's right. Let's go look up the name. Anytime you rely on your memory and it doesn't work, that's the first thing to check. So let's go look at on trigger enter in Unity 3D. And let's see, there it is. And oh look, that looks an awful lot like what we just did. So it's void on trigger enter collider. Oh my gosh, that looks exactly like what we just did. How about that? Let's hear it from my memory. All right, so on trigger enter collider other. Oh look, that's what I forgot. I forgot the other game object. Now this is a bit tricky, right? Which one do we want to destroy? This one says other.game object. What would that do though? That would destroy the ball. We don't want to destroy the ball. We want to destroy the coin. So we have a decision to make. Is the ball going to destroy the coin, or is it going to work the other way around? Is the coin going to destroy itself as soon as it hits? So this isn't the problem. But let's take one more look. On trigger, enter, collider, other, destroy game object. And they did theirs with no delay. Let's take that out in case I'm wrong. Maybe I just said 500 seconds. Let's try that. Okay, there we go. So let's go see what the documentation says with respect to what the delay time is. So there's on trigger enter, and it's not here. So let's see. We just need to find out what that overload is if we want to use it. All right, so there's the scripting reference, and let's find destroy. And it says this optional amount of time to delay before destroying the object. So it's not even telling us here what the unit of measure is. Great example of how you could do better in your documentation. The object will be destroyed now or if a time specified. Oh, see, it's t seconds from now. I made the assumption that it's milliseconds. And that's not a bad assumption because a lot of things work in milliseconds. So this would have eventually destroyed itself 500 seconds down the line, which is a pretty long time. All right, so let's do this again. Let's go back and change it so that it's a half a second. So now it wants 0.5 F. And let's see how that looks. Okay, so we'll roll it up here. You can tell I've played this game more than once. And that looks pretty good. Okay, so that's good progress. Let's save this. And now we got to figure out what to do next. So we need a score and we need a sound. The sound is probably the easier of the two. So why don't we try that next? Let's go out and find a sound that we can use. We can do, I'll try Sound Bible. I don't know if they're going to have anything good for us or not. Maybe they will. Okay. Maybe a nice cha-ching sound. That'd be nice. Ching-ching register, that might work. Let's see how that is. You won't be able to hear that, I don't think. That was really loud. Okay, so that's fine. It has an Attribution 3.0 license on it, so I'm required to then mention the person that did this. So let me go ahead and just take care of that now. Ooh, that's really loud. Okay, so there we go. And who did it? Recorded by Muska666. Okay, there's your shout out, Muska666. So consider attribution taken care of. I can download a WAV or an MP3. I would much rather have a WAV because that is uncompressed. So that's going to download. And it's telling me I need to buy one of these tile thingies because I lose my keys. So yeah, I should probably do that. We'll do that later. All right, let's find our file. There it is. I'm going to drag it and drop it in here. And there it is. All right, so where do I put this? I need to put this somewhere where I can play it. Okay, so what I'll do is I have to decide where I want to play it. I have a couple of options. I could put it on the camera. I could put it on the coin. I could put it on the ball. I could probably even put it somewhere off in distant space, somewhere it doesn't really matter. But I will talk about a few things really quickly. So I've got this sound selected down here at the bottom of the screen down here in Assets. And if I come up here and look, I can see that there are a number of things that I can change here. So I have these various settings for decompress on load, what compression format it is it going to be in, This isn't what it's in, it's what it's going to be in, and Vorbis is what you want. So you could change it to one of the other ones, but Vorbis is going to be compressed, and it's going to be the better of the three. These are going to be higher fidelity. So if you've got bandwidth and good music, then you probably want to go with one of these other ones, either pulse code modulation or adaptive. And those are great, but Vorbis is perfect for sound effects. So we'll use that. Now the other thing that it's going to want to know is, let me see. That's all good. Forced mono load and back. I was looking for the 3D sound setting and I'm not seeing it, so I will talk about that another time. So I think the strategy that I'll do for this is to actually put it on the coin. And so what I'll do is I'll select my coin again and actually go back into my script. And what I'll do is I'll come up here to the top, and I've got this little space here. So let me just add an audio clip, and I'll call it cha-ching sound for lack of better term. Sounds good, and it won't be initialized because there's no good way to do that. That means I have to remember to do it. All right, so now that we've got a spot for it, we just need to play it. So to play it, we really need an audio component. So let's switch back over to Unity, and with our coin selected, let's add an audio component. So if you find audio and find audio source, we'll click that and it'll add it. And now we've got this audio clip thing. Let's go ahead and drag that over. So I'm just going to click cha-ching and drop it right there. And there we go. And now it has this play on awake. You want to turn that off. That's good for music, but for sound effects, what's going to happen is it's going to play immediately as soon as you start the game. So that's not really what we want. So I'm going to turn that off. And now we've got everything we need here. So let's go back over to our code. I'm going to go ahead and save my scene so that everything's there. And switch back over to MonoDevelop. And now with that set up on our coin, what I'll do is I'll go ahead and get a reference to that audio component that I just added. We're going to do the same thing that we did earlier. So this is a pattern you're going to see a lot. Anytime you want a reference to something on the current object, you're going to get it pretty much the same way. We did this a moment ago with the rigid body controller on the marble. So we'll create a variable to hold it, and we'll call it, I guess we'll call it audio clip or control. Why don't we call it control so we don't get confused? Equals, and we're just going to get the reference. So it's going to be GameObject.getComponent. Don't forget it's the single version, not the plural version. And we want the type. It's pretty easy to guess. That's going to be audio source. And there's only one. You can only have one on there, so we're fine there. And now we just do audio control, which is the name of our variable, .play. And now we want to make sure that we have enough of a delay. The easiest way, of course, just to test it. But we could also go look and see how long the audio clip is. And if it's more than half a second long, then we probably will need to adjust this. But I'm just going to save this, and we're going to give it a try and see how it works. So I'll switch back over to Unity. And let's run this. Okay, so there's a little bit of a cutoff. And I know you can't hear that because I turned the system audio off, because I figured you'd get bored listening to my email ping every few seconds. It's a little bit distracting. But you should be able to hear that. In fact, why don't I go ahead and stop and then turn that back on? So hang on just a moment. Okay, we're back. Now I've got system audio enabled, so you ought to be able to hear this. Now I'm actually going to turn this down because, to be honest with you, it's killing my ears, and I can't because I'm using a really expensive breakout box, so I have to turn it down on the hardware. All right, so let's just do this. We'll run it, and you'll be able to hear it this time. It does cut off a little bit, so we want a little bit longer delay before it actually goes away. Now, a better way to do this would be with a coroutine, but we haven't learned nearly enough coding yet to be messing with that. So let's go ahead and just sort of cheat a little bit, and let's try 0.75 and see if that's a little better. Yeah, that's not bad. Okay, so I could spend a little bit more time adjusting that. I probably should really find a shorter sound or learn coroutines, but coroutines are later in the semester, and so we'll save that for another time. But the key takeaway is it's really easy to play a sound, especially when it's just, you know, the one sound that you want to play. Just attach the audio source, drag your clip on there, and then you just get a reference to it and access play. Now you can easily change the clip that's on there. If you wanted to change it to some other clip with code, then you could just do it down here. So it's easy to change those kinds of things. All right, so we've got a little bit of audio going on. The next trick that we wanted to try was to start showing some scores. Now, I'm a little bit hesitant to do a lot with scores because we want to do a whole section on how to use the user interface. So we'll do just the one thing that we need to get this done, but really I'm kind of opening a can of worms even by showing you this part, but we'll get it going. Okay, so what we want to do is we want to show the score. So we'll show the score, say, up here in the corner somewhere. And for that, we're going to need a user interface element. Now, in Unity 4, we had a different way of doing this. We had something called UI text or UI texture. I think it's UI texture. See, I don't even remember anymore. It's been so long. That's gone. If you have a game where that's in there, then you can still use it code-wise, but all of the options for inserting it into your scene are no longer in Unity 5. So later on when we talk about UI, and I think there's a persistence lab later, where we actually do some of that stuff with the old UI versus the new UI, you'll be able to see those kinds of differences. But for now, let's go ahead and do it with the new UI. This is an overhaul as of Unity 5. Actually, Unity 4.6 is where it was introduced, and then Unity 5 made it an official release. So for this, let's add the user interface element that will be required, which is a canvas. And I don't really have to add the canvas. I can just come up here, and I think usually I do it this way. I right-click over here in the hierarchy and find UI, but I think it's also up here under Create somewhere. Here it is, UI. All right, so usually what you do is go ahead and create the canvas, but I'm just going to go ahead and take a shortcut. I'm just going to create some text. So I'll click this, and you'll notice some things get added. So I've got a canvas, and it went ahead and added a text for me. I want to find where this text is now. It's not necessarily going to draw in a place that you're automatically going to see it. So let's go ahead, and you can double click it or you can hit F. The same tricks work no matter what. All right, so here it is. So let's go ahead and adjust this. So what I'll do is I'll go ahead and switch over to the 2D view. This is a 2D thing going on here. Now let me show you a quick rundown of some of the controls. Let me click on the canvas first. And there are a couple of things that are interesting here. So canvas, the first thing you usually want to consider is what render mode you want. And most of the time this one's going to work. Screen space overlay. So this is just going to lay the UI layer over your screen, which is whatever you see in the game window. And then there are other ones that you can use, like laying it over the camera, or you can actually have UIs appear in world space, which is a little bit exotic. We won't deal with that, but these are the things that you might want to take a look at when you're trying to figure out which one to use. We're just going to stick with this one. So this is going to cause the UI layer, even though it's disproportionately large, it's going to show up over our screen. So what I like to do is I like to switch to 2D mode just to make things a little less confusing when I'm looking at this. Now I'm looking at it the way it's really intended to be viewed. And let me grab this new text thing, and I'm just going to drag it up to the middle. And what this is going to do is this is the screen, and this is going to be where it's showing. And let me go ahead and put something in here so that we can see it. We've got this font size here, so why don't I go ahead and bump this up to something a little bit bigger so that I can see it. I like even numbers for scaling purposes. That's fine. We'll go ahead and right align it because we're going to, well, we just move it where we know it's going to go. It's going to go up here. And that is fine. So I'll leave it there. And I'll save everything. And now let's run it. And I should see new text up in the top corner. And there it is. So before it was on the screen, but it was kind of down here, and I think the pattern sort of obscured it if you couldn't see it, but it's there. So that's where we're going to put our score. So let's go back and make some adjustments. And what we need is, first of all, to name this. It says text on it. That's not very descriptive. Why don't we call this score display? And now that's named a little bit differently. And we can leave new text there. It's not that big a deal. It's not going to hurt us because we're going to immediately change that in our code. But another thing you might want to do is change the font. So you can use pretty much any font on your system. All right, so this is my font folder on the Mac. It's under your hard drive, library, and then fonts. And these are all the fonts that you have installed. There's a similar location on Windows. Shouldn't be that hard to find. If you don't know where it is, just Google it and you'll find it. You can also download fonts from the internet and just use fonts. So what you're looking for are TTF, true type fonts, or these are OTF. I'm sure they'll work just fine too, but I usually stick with TTF fonts. And my personal favorite happens to be Comic Book, not Comic Sans. That's the cheesy Microsoft one. I have one called Comic Book in here somewhere. That's pretty cool looking. But I don't see it, so I'm not going to spend a bunch of time looking for it. I'm just going to pick one that is hopefully somewhat... oh, that's really distinct, right? That's a little too distinct. Let me see. See if we can find something interesting here. Okay, that looks kind of cool. I'll use copper plate. Actually, that's a TTC. Let's see if we can do... Let's just use this one. That's not going to look very good, but I know it'll work. And I don't want to use Comic Sans because I've already bad-mouthed it, right? So I don't want you thinking badly of me. So I'm just going to take the TTF font that I like. Just find one that you like. Download one if you like. Make sure you have rights to it because it's an asset just like anything else. But you can just take this TTF and you can drag it down into your assets. And once it's in your project, then you can, with the text events or the text area selected, we can find our font. There it is. Drag it and drop it into the font slot and it will change the font. Okay, so that's not the prettiest font, but you get the idea. You can use any font that you'd like as long as you have a license for it. All right, so that's there. All we need to do now is make a few changes to our script. And actually, we do have to do a little bit more work than this. In order to make this work, what we're going to need is a game controller. So a game controller is usually implemented as sort of this empty game object that sits up there above it all and acts as sort of an integration point. So I'm going to go ahead and create an empty game object, and this is going to be my game controller. So let me name this game controller. And I'm going to go ahead and use a tag for this. So this is a way of allowing us to get at this object. This is one of the really complicated things about Unity programming is finding a way to get a reference to some object that's over there in the hierarchy. There are a couple of different ways, and we're going to have a demonstration just on that because it's so important that you know how to do this. So we have game controller. I'm going to go ahead and tag it as game controller, and then I'm going to go ahead and add a script to this. And I'm going to call it, guess what? Game controller. I'll call it game controller script though, so that you know which one we're talking about. So I'll click create and add, and there it is. And why don't we create a private property for this, or public property for this, and we'll make it an integer, and we'll call it score, and we'll set it equal to 0. All right, and then the other thing we'll do is we'll go ahead and create a spot for our text, or the actual text display for it. So I mentioned there's several different ways to get a reference to something. I think you're going to see all of them right now, in spite of the fact that I told you you're going to see a nice demonstration focusing on that later. It won't kill you to see it multiple times, because again, this is important stuff. So we've got our score. We need to know where we're going to display it, and so why don't we make something called public text, and it's not going to work, score display. Why isn't it working? Why did he say that? Oh my gosh. He's lost his mind. Let me see. Oh, look, the time is after 9 o'clock. I am fundamentally allowed to lose my mind. But in this case, I have not. What I need to do in order to get this to work correctly, and it's going to say, I'm surprised it isn't giving me a little wiggle down here, a little red underline. If I try to build this, it's not going to work. It should say, I have no idea what you're talking about here. And that's because we have not imported the right namespace for this. So most of the time, all you really need is Unity Engine. You don't really even need system collections unless you're actually using a collection. And we usually, at this stage of the game, we haven't talked about them yet, so we're not using any collections. But in this case, we need one more thing. So I'm going to add using Unity Engine .ui. And that allows us access to all of the UI capabilities. So basically what happens here is we have these things called namespaces. So a namespace would be Unity Engine, system is a namespace, and then another namespace under system is collections. It's just a way of organizing code. If you take in Java, then you know about packages, and it's the same basic idea, but packages in C# are a lot more flexible than they are in Java. So in Java, they have to be a file structure. They have to conform to a folder directory structure. And that's not true in C#. You can pretty much do whatever you want with your namespaces. If you've used Visual Studio in C# outside, or I should say C# in Visual Studio outside of Unity, you might notice that's missing. There is no namespace at the top of these classes. That's because Unity is generating that for you. It's keeping everything in one place in one assembly. That's why it says assembly C# over here. That's actually the namespace that it's using for everything. But namespaces are nice. They help you organize your code. We just don't use them in the context of Unity scripts. So that's why, and the text, all of the things that go into the user interface elements, those are kept in a namespace that we haven't included in our compile path yet. So that's what the using statement does in this context. It allows us to access classes that aren't normally included with the standard monobehavior or C# libraries. So with that in there, we should now be able to build once again. And now we're okay. So what that lets us include. Now this is not the same thing. I almost said include. This is not the same thing as a C++ or C include statement. In C and C++, especially the old school stuff, what that did was it actually went out and it copied a file and sort of pasted it behind the scenes into your code and then compiled the whole thing. And the bad thing about that is that it causes code bloat, right? So if you put some stuff in there that you wound up not using and you forget to take it out, then your program gets bigger and bigger and bigger, and you have all these dependencies that aren't really dependencies, and things can get kind of nasty after a while. So you have to go through and clean all that out. In the case of a using statement, it's the same as an import statement in Java. This is true for both languages. All this does is it points to a location so that when we build, it knows where to find these classes. So it doesn't actually copy and paste anything and bloat up your code. It just really just points to the location in the library where it can bring those things in. So there's no penalty if you have stuff in here that you wind up not using later. In Visual Studio, it actually gray them out for you. It'll change the color of this so that it actually looks different. But what'll happen is it'll just say, oh, well, you have this using statement here, but you never used it, so we're just going to disregard it. And so it's fine. It's not that big a deal. All right, so we've got that in there now, and we've got our score text display, and we have not set it. There's no good way to set this other than setting it directly by dragging and dropping. So why don't we go ahead and do that now while we're thinking about it, because frankly, this is something that I always screw up. I forget, and that makes me look silly in class. So I'm glad that I'm doing it, remembering to do it now so I don't look silly in the recorded lecture. All right, so we've got our game controller. Now we can see, oh, there's our score display. It popped up in there once we built. And so now all I have to do is find my score display over here. I'm going to drag it and drop it right there. So let me do that. I'm going to drag it and drop it right there. And now there's this sort of permanent linkage between these two things. I'll always have a reference to it. So that's one way to get a reference to an object in Unity. The other one we've already seen, or I should say another one, there's more than one way. Another one we've already seen is by using the GameObject's getComponent method. And that gets a reference to an object, but it gets a reference to a component that's on the current object. The next trick I'll show you is how to get something by tag. If you remember, we set this up with a tag. This game controller has a tag on it. So now we can get a reference to the game controller object from any other object just by finding it based on its tag. And you can find it by its name as well. I could find it by game controller, the name. The problem with that is you may change the name. And if you change the name up here to something else, you have to go back and change your code, and that's kind of lame. So tags, pretty cool. You can just go ahead and set up tags, and then you can change the name all you want to and not have to worry about it. All right, so let me go back into my coin controller, and that's where the action is happening on the trigger. So what I want to do is I want to go ahead and do something with the score. So here's what I'll do. I don't want to set the text on that thing directly. I could do that, but that's not really what I want. What I really want is to access some sort of method that will do that for me. So I guess really I should start on the game controller script. Let's do that. Let's add a method on here that we can access that will do this for us. So most of the time in here you're seeing these event handlers that you get automatically, but we've learned in our object-oriented labs that we can make our own stuff, right? So let's make our own thing here. So let's do public, and we'll do a void. Since it's not going to return anything, it's just going to change the score, and we'll say add points. And then we'll take an argument. How about how many? And that will be an integer. I got to put int in front of it, like so. Oops, there we go. And now all we have to do is just say score. I'll do it the long way. I'll do score equals score plus how many points. Okay, so that's the long way to do it. Let me show you another way to do it. I'll comment this out, and I'll say score plus equals how many points. Those two statements are exactly the same. They mean the same thing. But you're going to see the one on line 21 more often than you're going to see the one on line 20. It's a shortcut. Once programmers learn to do it, they pretty much never look back. So that's what that means. It means score equals score plus how many points. And now we're all set. There is one more thing that we need to do, and that's actually display the score. Let's use update for that. So this is going to fire 60 times a second, which is pretty darn fast. So we can be assured that we're always going to be showing the correct score. So we'll say score display dot text equals score dot toString. Now we don't really have to do toString. It'll cast it for us automatically, but why not showcase the ability to cast something to a string since it's so very easy and it's easy to remember. All right, so that looks pretty good. Let's save this, and now I should be able to run this and actually see the 0 up there at the top. So there's my score 0, and that's fine. So let's stop this. Let's go back into our script, and let's go into our coin controller. And now what we eventually want to do is we want to access this add points method. Remember, we made it public because we want to be able to access it from any other object. So that's important that it be public. Let's go back over to our coin controller, and what we need, let me set this up for you. We need a reference to the game controller object. And then once we have that, we need a reference to the game controller script. That's why we named it differently. I didn't want that to be confusing, which is on the game controller object. Okay, so if you're having trouble wrapping your brain around that, let's go back and look at it visually. The game controller has on it a game controller script. So remember, composition allows us to make objects out of other objects. So here we have a game object called game controller. Game controller, that's the name of it. And we've added a component to it, another object called game controller script. Now usually I'm tempted to just call it game controller, but then we'll have game controller dot game controller Since this is the first time, I didn't want you to get confused, but I'll probably do that in the future. Okay, so game controller script. We're looking for the reference to both of those things. Once we get the game controller reference, then we can get the game controller script reference pretty easily, right? So this is the only thing you haven't seen yet. You haven't seen how to get something by tag. So I'll say controller object, and I'll get that based on the tag. So the way to do that is the big game object, big G game object. Finally, we're busting that bad boy out. Dot find game object. Remember single versus plural? Game object with tag. We want the singular one. And now we just need to know the tag. So it takes a string. And that would be, let me scoot over so I can remember what I called it. Oh yeah, game controller. I was not very imaginative. So there's the name of the tag. Okay, so that will get us the game controller object, and that'll give us back a game object. All right, so once we have that, we can say game controller script. This is going to be the reference to the script object. Is, see if you can figure it out. We've done it before several times. See if you can think about it. So it's we have this game object, and now we want to get a component on it. So if you guessed get component, you're absolutely right. Controller dot get component. And now we need the type. What's the type going to be? Well, the type is the name of the class. So what's the name of the class? You can see it right there. The class has to be the same name as the file. That's a rule in Unity. So we can say game controller script. That's the name of the class. Okay, so the only thing that would get you in trouble here is if you had more than one on there. And I don't know what happened if you had two on there. So let's just not even think about that. So game controller script, we now have a reference to that. Now that we have a reference to that, all we have to do is say game controller script dot, oh look, there's add points. That's the public method that we created. So we're going to add points, and we could say 100 here, but it would be better if we came up here to coin controller and add a public method, or a public property, excuse me, called point value. It's an int. And we'll default it to 100. How's that? But that way you can make some coins worth more than others, and that's nicer than just hard coding it. There we go, and then we'll say point value here. And that's pretty nice. All right, so let's see how that works. Switch back over to Unity. We can turn off 2D mode. Probably be a good idea to focus back on our marble. So let's go back so that we don't lose sight of our game. Just sort of get us in the right mode, and there we go. So now we should be able to roll through here. And, oh, something happened. It didn't work. So it seemed like it did something for a quick second there, but let me go back and check and see if I did this right. Let's see. It was marble controller. And we're adding 100. Oops, that's the wrong one, isn't it? Coin controller. We're adding 100 to it. So we should be able to see that, and let's just make sure this is okay. Score equals 0. How many points? It should work. Let me try it again, make sure I didn't. Thought I saw it change and then change back. Let's just go look. No, it didn't work. Let me think. Let's see. Why is it not working? Maybe it's disappearing before it has a chance. All right, hang on. Let me see. Okay, I've looked it over. Frankly, I thought that would work, but in thinking about it, I mean, obviously it doesn't, but why does it not work? And I think it's a reference problem. So this is something we can try really quickly, and it'll also reinforce another thing that we talked about a little bit earlier, and that's a static value. We talked about static classes, static values, and so let's try that now. So I think what's happening is we're getting a different reference to score than we're actually displaying. So that's something of a problem. So this is a perfect application for static. So if we come into, we're in the game controller script, and here's our score variable. If I actually just come in here and change this so that it's static, then what this means is there's going to be one copy of it in memory. So all objects, regardless of however many ones there are all going to point to the same place. If you want to be a C++ programmer and you want to think about pointers, this is probably as close as it gets. So all values or all instances are going to have the exact same value, but because you're making this static. Now, a lot of people make the mistake of thinking that that makes this so that you can't change the value of the variable. That's not right. It means that everything has one version. They're all pointing to the same value. And so that's really handy here because that's going to negate any of these effects that I suspect we might be seeing. So let's see if that fixes it. So we've changed this to static. That's the only change I've made. I'll make sure this builds real quick before we switch back over in case I'm horribly wrong, and I don't think I am. Okay, so build was successful, and let's run this. And now we should be able to see this change. And now we've got our 100 points. All right, so I think we're on the right track now. So I guess really the only thing left is to sort of duplicate this coin over and over again. Now this is a basic concept in Unity, and they're called prefabs. A prefab is basically an object, a game object that you've set up. So think about this game object for a minute. I've got the canvas in the way, don't I? So let me move out of the way so I'm picking the coin. Okay, so that's fine. Now we've got the coin, and what all is on this coin? There's a lot of things on this coin. There's a collider, there's an audio source, there's a coin controller script, there's a texture. All of that stuff together, wouldn't it be great if you could take all of that and make a reusable object out of it? Well, you can, and that's what a prefab is. It might actually be really smart from a production standpoint too, to go ahead and tag this. We don't need it for our immediate efforts, but it's probably a good idea to do this. So let me show you how to do this. Let's go to tag, and then we could use one of the ones that's already here. Like earlier we used game controller. Why don't we add a tag? So we'll add a tag, and it's a list is really all it is. So we'll click the plus sign, and we'll add a tag, and I'll call this collectible. And that's great. But we haven't applied it yet. So let's go back over and click on our coin, and now let's set our tag to collectible. And that'll actually come in handy. We're going to do a refactor here in a few minutes that will make good use of that. So it's tagged. That's awesome. What we want to be able to do is reproduce these things. Now I could just copy and paste them, but that's not the best way to do this. What we really want to do, again, make a prefab out of it. To make a prefab, come over to your hierarchy, select the object that you want to make a prefab out of, and just drag it down into your assets. And when you do that, you'll notice that it turns into a blue cube. And you'll notice too that coin becomes blue up here in the hierarchy. That's your hint that you're looking at a prefab. So the great thing about a prefab is it becomes essentially a class at that point. So it's all of these things set up with all of these properties on them, and all of the components are there, and everything is set up just so. Now I can drag as many of these out as I would like. And they'll all be instances of the same thing. So the only thing I have to be careful about is the height, right? So I'll drag a few of these out. And there we go. All right, so we've got multiple coins out, and that's pretty neat. And they'll all work together, which is equally neat. So they'll all spin together. Now I can change these things individually. So I could come over here and I could do something to this thing. and it would be independent of all the rest of them. So if I really wanted to make this a different color, I could change the texture, I could change any of the parameters here, and it would only affect that one. Just like in object-oriented programming, we can make a change to an instance of the object without changing all of the other instances of the same object. Or I can choose to make a change permanent by making it part of the class, if you will, by changing the prefab. And the way we would do that, I don't have a good demonstration in mind for you, but I'll just point it out. If I make some change to this, like for example, if I change, we'll say we change the scale on this to something like 2. Okay, now you've got a great big gigantic coin. And let's say I wanted to, I can actually go ahead and leave that the way it is, assuming I hit enter, and it will only affect that one. And you know, we have one giant coin and the rest of our normal. Or with that gigantic coin selected, I can come here where it says prefab and I can select apply and it'll make all of them gigantic. Or I could say, well, you know, that was a huge mistake. I'm going to click revert and put it back to what it was. So we have the ability to make this sort of global change very easily. So these are the things that prefabs are great for. And the other thing that is pretty much a must-have with respect to prefabs, you must learn how to use these things. These are the only way that you can spawn an object into a game with code. So you have to make a prefab out of it. So if you have an enemy that's going to run around, and if maybe it's an enemy that you can shoot and they go away, you want other enemies to show up, and they're probably going to be copies of the same object. So that's what prefabs are good for. You can respawn and put them different places and do different things to them. So that's really what prefabs are great at. All right, so this is not a bad little game. We've had a good long lab and we've seen a lot of different features. There was one more refactor that I wanted to show you, and then we'll call it done. Let's go into our coin controller. Oops. Coin controller script, my bad. Hey, I told you it's getting late. And actually I was thinking about the collectible thing, but that's not actually going to work. So what I was thinking was we're going to check the collider to make sure that it's a collectible before we collect it. The problem is that I went the other way. I didn't do this from the ball. I did it from the coin's perspective. So we'll have to do it a little bit differently, but I'll go ahead and show you what I was thinking of. If we go into, actually let's go into, where was it? It was in coin control. Here it is. All right, so when we do this, what we want to do is we want to check to make sure that the thing we expect to be colliding with us is actually the thing that's colliding with us. So we had an enemy running around. We wouldn't want the enemy necessarily to be able to collect the coins, right? So let's make one more change to this. And to make this work, why don't we check our marble and see if it's not tagged. So let's go ahead and change this. We'll tag it with player since that's right there in handy. It's built in. Let's go ahead and check and see if whatever is colliding is the player. And if it is, then we'll do all this neat stuff. And if it's not, then we won't. So this is something that's pretty common. That's why I want to make sure you see it. We'll say if other.gameObject.tag. You could do compare tag. Be honest with you, I just like tag better. Equals. Remember, it's 2 equals when you're doing a comparison. Player. Oops. There we go. And then we'll just enclose all of this stuff in our curly braces. And I don't know if there is a format command in MonoDevelop. I'll check here in a minute. In Visual Studio, there definitely is. It would go ahead and fix this for you, but I'll go ahead and fix this manually. So I just selected the whole thing and hit Tab, and now it's a little bit more legible. All right, so that's a nice little qualifier, nice little refactor for us. So now the only thing that will cause all of this code to execute is if the thing that collides with it is tagged player. And so that's just a nice little safety measure. All right, so let's do one more check and make sure it's working correctly. Okay, not bad. It's not perfect, but we don't have time for perfect. Okay, so it's working pretty well. It's doing everything expect it to do. Oh, there's one more thing that we didn't do, and that was the camera follow script. Always seems like there's one more thing, right? So let's do that real quick. There's nothing to that. Yeah, sorry about that. I guess I thought I was finished. There's always one more thing, right? So let's go ahead and create a C# script, and we'll call this camera controller. And let's go ahead and drag this onto the camera. So I'll select the camera, and I will select camera controller and drag it and drop it on there. So I'm kind of really showing you every possible way to do this, right? We've added component directly. We have dragged it and dropped it. I think those are the only two. I'm trying to think if there's another one. I guess there's not. Okay, so that's good. So camera controller there. Let's open this up. This is really short, so I don't feel too badly that I forgot. So let's just add something in here. We need a reference to the player now. We're at a crossroads, right? We now know how to do this. There's lots of different ways. We can drag the reference. We can use the tag. There's lots of different ways to do it. So why don't we do the dragged reference, because I think that's a good one for you to get used to first. So let's do public game object. Actually, what we probably want is the transform. We really probably don't care about the whole game object. We care about the transform. So this will be a neat little trick. I'll do a transform, and I'll call it player location. Right, so that's there. Let's save this. And let's switch back over. Now this is kind of cool. Watch this. We'll do, there's the main camera, and we can see our player location is here. And we're just going to drag a reference, in this case marble, and we're going to drop it right there in player location. But this is a transform, right? But this over here, what is this? This isn't a transform. It's a game object. But every game object has a transform on it, right? So watch this. When I drag the marble and drop it on player location, it's going to go ahead and just get the transform part of it. It's going to disregard the rest. So it's automatically doing this sort of casting for me, which is pretty cool. All right, so it's just going to disregard the rest of it. We've got our transform, and now all we have to do is compute some sort of offset. So we're just going to have the camera stay a certain distance away at all times from the object that it's pointing at. And this is really pretty much the simplest camera follow script that you can do. There are much fancier ones that you can do, like you can have them sort of zoom and pan and do interesting things and zoom in and out and maybe make walls transparent. There's all kinds of things you can do with your camera controller script, but this one is the simplest one that you can do. So let's go make this happen. So I'll just double click this as an easy way to switch back over. And now all I'm really going to do is I'm just going to change the location of the camera based on the location of its reference, which in this case is player location. So in order to do that, I really need to store what the offset is. And I'm going to kind of do this the easiest way possible, which is just to go ahead and take whatever's in there already. There it is. Whatever's in there already. So let's switch to the game view so you can see what I'm talking about. Okay, so I'm just going to fix it so that whatever it is here at the beginning of the game, that's the offset, and it's always going to be exactly this distance away. So that's pretty easy. So let's do that. So what I'll do is I'll create see if you can guess what kind. I need to hold a three-dimensional coordinate. So what type do I need this to be? I'm going to make it private because only this class needs to be able to access it. And what type is it going to be? If you said vector 3, you're absolutely right. So it's vector 3. I'm going to call it offset like so. Oops. And then I'll set my offset in start. So I'll say offset equals, and what I want to do is subtract the camera's location from the player's location. Well, I have the camera's location because this is on the camera itself. So it's basically just going to be transform dot, I want to say location, that's not right, it's position. If you get stuck, you can always sort of move all your windows out of the way and go back over here. So transform dot position, not location. For some reason I'm thinking location. Let's go back and get that back. So let's do transform dot position minus, and now we want the player's position. So we have player location as a transform already. So now we can just say player location dot position. And it will go ahead and do that subtraction with all 3 points in that vector automatically. So it's kind of nice. We don't have to do a lot of vector math. It does all of it for us. And that's the great thing about the Vector3 class. All right, so now we have our offset. All we have to do now is update our position based on that offset. So that looks like this. So we'll say transform. Now we're talking about the transform on the camera because that's where this script is. Transform dot position equals player location dot transform. Oh, it is a transform dot position plus the offset. And let's see how that works. Okay, good. Now as we move our camera, or as we move our ball, the camera should follow it, which makes for a more playable game. And now you can envision making a much larger level, and this marble game would actually be something kind of fun. You need some sort of pressure to make, or some sort of risk to make this worthwhile. Maybe you could make an enemy that follows the ball around and tries to get it. Maybe you could make it time-based, survival-based, something along those lines to make this a little more interesting, because rolling around picking up coins is not all that compelling. But we learned a lot of techniques. Hopefully a lot of them are reviewed, and a lot of them were probably new, and a lot of them were probably explained in a different way, or perhaps hopefully better than they were explained in the Unity video, just because we're going into a lot more detail. You might notice that this one took a couple of hours to go through, assuming I've done a decent job editing, and it's certainly taken a couple of hours to record it. So hopefully you got a lot more detail out of this one. Obviously, if you have questions, let me know what they are. And well done. You made it through the end of the first big lab. More to come.